Hello, welcome to this presentation on SNMP exploits for SIT 716 network security for Deakin University. I'm wearing my hacker's hoodie. Awesome. Let's get into it. We'll start with a presentation and then we'll go on to do a bit of SNMP hacking. So start the slideshow and SNMP exploits. Today we'll focus on the bulk get, reflect and amplify attack. But first of all, before we get into it, what is SNMP? It stands for Simple Network Management Protocol. A bit more about that later. So during this research project, I've researched SNMP and its programming, intercepted SNMP messages with Wireshark, extracted information from those messages. We've explored a SNMP exploit with a focus on version 2C, which is one of the most common in use. Researched the object ID, the OID or OID, which is the underlying protocol of MIB, which is a standard way that SNMP protocols are expressed. And we're going to install and program SNMP as a possible malware abuse. And lastly, after researching all this, we discovered that the standard use and monitoring of SNMP is something much different to the path that I took to explore it, which is very interesting. So what is SNMP? Right, most devices, be they a gateway or a switch or a router or a power supply unit, they have a little communications device in there, and that sends messages. They can be sent without being asked for, in which case it's called a trap, or it can respond to a query, in which case it's a polling from the manager. The manager is the base client, and the agents are the servers. So what is SNMP and why is it important? Because it tells us the state of the networks, and this includes firewalls, IoT devices, and it's been around for about 30 to 40 years, and so it's well embedded in many systems, especially legacy systems that are still in use today. Here it is monitored by Nagios software, and so as you see it's giving this could be Grafner. Anyway, it gives lots of readouts as to how things are performing, charts and graphs, all very interesting. You can see here a bit more. Nagios, as a system monitor, places itself in the middle between the objects, switches, routers, database servers, so application servers, anything else that might be on the system, including power supply units, firewalls. Now they all report to Nagios, which will then make its report in a software form to the user. And then those reports all get aggregated into local system monitoring, So we're looking at the health of a number of different networks. Each of these networks are often informed by the underlying SNMP protocol. And here we have from AT&T a global system monitoring, which is a aggregation of all the local monitoring systems, which in turn is aggregation of all the local systems, which is informed by the SNMP protocol. Right, so it does have ramifications as we travel up the pipeline. So I mentioned something about the reflect and amplify attack using SNMP. One particular command, the SNMP bulk get, asks the device to send all its information, not just one single status, but as many commands as it has. So here we have got a gateway and a modem and a firewall and a printer and a scanner and a projector, and all these have or can be SNMP servers. And so the SNMP bulk get sends a request to the device and tells it to report its information, which could be up to 100 lines of information or more, and can direct that to a third party. So just a single notification to each device can result in 100 notifications from each device, in this case adding up to 600 notifications flooding the system. And if we have R2, we double that, and we have a whole network of bots demanding the network send their SNMP bulk get notifications, and we'll end up with something approximating a dedicated denial of service attack, flood the system. And these can also send the false message, such as system down, system power up in the process of, thereby poisoning the system. So all our chappies here at the global networking system, suddenly, boom, no more information. And that is the importance of SNMP in this situation. Alright, so we've got the MIB protocol, which is the management information base, and that's a verbose layer that sits on top of the OID layer. For example, using the MIB protocol, we get the IP forward command. Now in the OID, or the object identification, it is expressed as a series of integers, and as they increase in length, they drill down into the actual information required, granularity. So in this case, this asks for IP forwarding table description, or we can get the IP MIBs and ask for the system stats table command, which in the OID we have the first section of integers 1.3.6.1.2.1.4, which is the IP MIB. See, that's the same up here, so it's referring to the MIB command. And then the 0.31.1.1.31 is the HC out transmissions. So this is one part of the module for managing IP and ICMP messaging. So the amplify and reflect again, we can see here we got the SNMP bulk get command being delivered to a network device and then redirected onto a victim's computer. So there's been a bit of research to put this together. The output of the work has been a deeper understanding of the SNMP OID protocols and the underlying exploits that are possible, weaknesses in the network, and get an idea of exactly what's possible with the SNMP protocol. So I've learned about some programming, SNMP daemon, which is a way to send and receive SNMP requests, and by using it on different devices you can mimic the usual SNMP devices on a network. So it's a pretty deep observation, because when we look at the numbers, we see at the start, this again here is defining the enterprise, and this number here is the Nagios. And then we're talking about identity of what? This one's an SNMP trap. And within this we get notify type, host state ID, host state type, service state ID, which are all different parts of the information available by request. And accessing that, this is a screen of the virtual box where we have the SNMPD service that's up and running, it's active. We have 6 bots set up to issue the command. This is a result from 2 requests where we get 100. Yes, up here, CR 100. We've made 100 requests. That's caused the agent to return all that information. In fact, we got it to return over 2,000 responses. And here we see the bulk request, and then the response, which is almost a kilobyte. And we call it an amplification because it's like 12 times as much as the request size. All SNMP directed to port 161, which is dedicated to the SNMP network. And we see here this is frame 2179. And this was in 6 seconds. And vulnerabilities, here we have the community word. This is like the password of the system, and this is set to public, which is the default. And apparently in the last report, 72% of SNMP systems used the default community string setting. So got a minute left, so quickly just have a look at in action. So here we have the SNMPD service up and running. Now we can send a bulk get message 100 times to using the version 2C. It's still got the public password. Here's the destination IP, and here's the bulk get command. So we'll send that, and there we go. We've got quite a number of returns happening from a single request. And the other thing we can do, we can send a bash script. And as we see, that takes a bit longer to return, as there's a lot more information happening, and it's a bit more complex in what we're asking for. And so we only need to send that a few times. And let's see, what does Wireshark say? Right, so let's get ready to send it again. We'll start our monitoring. Off we go. Boom. Stop that. So there we got a heap of responses. We've got a bit of a flood happening. All on the SNMP, flooding the 161 port. And that's our reflection, or a portion of the reflection attack, because this is just going to a single agent. If we magnify that by 60 times or 100 or 1000 times, then we have a DDoS attacking action. Right. So that's about it. Thank you for the little hacking demonstration, audience, and stay safe.